Hello everyone. So today we are going to start our mathematics class of A2, and today our chapter of study is the vectors, and more specifically today we are going to study the vector equation of a line. Okay. So today we are going to discuss about the vector equation of a line. Now let's first discuss that what is the meaning of the term vector. All right, what is the meaning of the term vector? Okay, now vector is actually okay. So vector, I'm sorry. So vector refers to the number of steps that you have to walk. Okay, so it refers to the number of steps that you have to walk in moving from one point to another point. Okay, so vector usually refers to the number of steps that you have to walk in moving from one point to another point. Okay. Now the steps may be counted in various manners, like for example, let me tell you first that suppose this is a coordinate axis that consists of the x axis and the y axis. Okay, so the x axis, so this is 1, this is 2, this is 3. Okay, this is 1, this is 2, this is 3, this is 4. Okay, so for example, consider that here is one coordinate point. Okay, so here we have one of the coordinate point, and here we have another coordinate point. Okay, now tell me, if you want to move from here to here, then what are the how many steps you need to take? Okay, so here you look, you have two ways of movement. Okay, either first you can move, either at first you can move along the x axis. Okay, and then you walk along the y axis. Okay, or you move from here to here directly. Okay, these are the two possible ways you can move from this point to this point. Okay, but let's see whether they gives the same result or not. Okay, oops, I'm sorry that I have to draw it again. Okay, let's see. Okay, so here it is 1, here it is 2, 3, then 1, 2, 3, 4. Okay, and here we have one of the coordinate point, which is 1, 2, and here we have one of the coordinate point, which is 3, 4. Okay, and now we are planning to move. Suppose this point's name is point A and this point's name is point B. Okay, so what is vector? It is just the number of steps that we need to take in going from one point to another point, either directly Number 1, it's either directly, okay, or along reference. Instead of reference, we better say specified number axis. Okay, like in this case, this is the y number axis or vertical number axis, and this is the horizontal number axis. Okay. Now let's go into the steps that we need to take. First, along the referred mathematical axis. Okay. So if you want to go from A to B along the x axis, look, let's draw an x axis over here, and let's draw a y axis over here. Okay. So now count how many steps do you have to go along the x axis. So this is 1, this is 3. So you have to go 1 step and then 2 step. Okay. And okay, so how many steps do you have to go along the y axis? So from here to here, all right. So you have to go 1 step, 2 step, or let's draw it over here, 1 step and 2 step you have to go. Okay. So along the x axis, you have to take 1, 2 step, and along the y axis you also have to take 1, 2 step. Okay. Okay. So if you want to go from A to B, then you have to move 2 units along the x direction or x axis and 2 units along the y axis, for which we are saying it as 2, 2. All right. Okay. So this is the meaning of the vector, that these are the steps. That means 2 steps in x direction and 2 steps in y direction. All right. Okay. And so how many steps do you have to take directly if you want to go from A to B? Okay, so let's rub it. Okay. Okay. So if you want to go from A to B directly, okay, then how many steps you have to take if your each step has a value of 1, then how many steps you have to take? This is the modulus of the equation. Okay, this is the modulus of this equation. Like let's say, for example, what do you mean by the modulus? Okay, so from A to B we have to take what? We have to take 2 steps in x direction and 2 steps in the y direction. Okay. So the modulus, so we would say that vector AB, that means from A to B, okay, from A to B we have 2, 2, that means 2 units in x direction and 2 units in y direction. And the formula for finding the modulus is, if a vector is given as x and y, so modulus of the vector or length of the vector would be equal to root over x square plus y square. Okay. So this is the formula for the modulus of the vector. Okay. Now the thing is, what is the modulus of this vector AB? Okay. So the modulus of this vector AB would be root over 2 square plus 2 square, which would be equal to root over 2 into 2 square, that means 2 root over 2. Okay? That means this is the modulus of the vector AB. That means you have to take this number of steps if you want to go directly from A to B, and each of your steps has a value of 1 unit. Okay? And if each of your step has a value of 1 unit, then we call it the unit vector. Okay? Now, let us go into some more details. Now, we were focused on the so this is the vector. Okay? We were focused on the vector equation of a line. Now, what do you mean by an equation from a graph? Okay? An equation from a graph, it has to be in such a manner that it would tell you about the coordinate points found on a line. The equation of a line in a graph has to be such that they would tell us the coordinate points, they would tell us the coordinate values of all the points on the line. Okay? Now, do you know the meaning of coordinate values or coordinates? Okay, look, we have a starting point here. We have a starting point over here, which we are calling it as the origin, and whose coordinate is 0 and whose value is 0, both in the horizontal axis and in the vertical axis. Now, when you are counting the number of steps from the origin for each point, then we are calling it as the coordinates, and the vector we are writing, we are calling it as the position vector. Okay? Like what I am trying to say is that when you are writing AB is equal to 2, 2, then you are mentioning the position of B with respect to the position of A. All right? So, this is not the position vector of B, but if you write OA, that means you are taking the position of A from the origin, then the number of steps that you are writing in the format of commas is what we call the coordinates. That means from O to A, if you want to go, then you have to take one step in x direction and 2 steps in y direction. So, it has to be 1, 2. So, this is the coordinate that when you are writing in the form of comma, but when you are writing in the form of this bracket with up and down format, we are calling it as the vector. So, if you want to go from A to O to A, then you have to move 1 unit in x direction and 2 units in the y direction. All right? Okay. Now, the fact is that we do not always go along the axis. Instead, we sometimes move along the line that joins the point. That means directly from one point to another point. Now, the thing is that you have to take steps, right? You have to take steps. Now, each of your steps might have a value of 1 unit, or each of your steps might not have a value of 1 unit. Okay? By 1 unit, I mean that you are taking 1 step in x direction and 2 steps in 1 steps in x direction and 1 step in the y direction. Okay? However, this is also not the case in most of the times. Now, 1 unit actually means that the vector you are applying, or the vector you are saying are talking about has a value or the length of 1 unit. Okay. So, if each of your steps has a magnitude of 1 unit, then we can use the length of the vector as the number of steps that we need to take. Okay. So, first let's find out that how to find a unit vector. Okay. To find a vector whose which would express that each step would be equal to 1 unit. Okay, so let's see how to find a unit vector. If a vector, for example, we are taking 2 points. For example, this is a line and this is point A and this is point B. All right. So, if you are going from A to B, then you have to move stepwise. Okay. And if you want that each of your steps should have a value of 1 unit, then you have to find a unit vector. And unit vector is equal to 1 by magnitude of AB multiplied by the vector itself. Okay. So, this is how to find the unit vector. Okay. Now, what do you mean by that? Each step should have a magnitude of 1 unit. This actually means that, let me tell you, for example, this for example, this is a road on which you are walking. Okay. Now, this is 1, this is 2, this is 3, this is 4, this is 5. Okay. Now, consider that you are walking like this. Okay. Okay, so you are walking like this. Now look at the difference between your between your one step. So your one leg is at 1 and the second leg is at 2. So what's the difference? 1. So the vector here for each of your step, the vector would be called as the unit vector. Okay, all right. Now, if however your steps are not like this, instead your steps are like this. Okay. So look, your one leg is at 1 and another leg is at 3. Okay. So, so each of your vector is so each of your step is now not equal to a unit vector. Okay. Each of your steps will be equal to 2 units. Okay. Okay. So here we will say one step would be equal to 2 units. Okay. One step would be equal to 2 units. And how do we find the unit vector once again? Unit vector is equal to 1 by magnitude of the vector or length of the vector multiplied by the vector itself. Okay. Okay. Now tell me the meaning of position vector. The meaning of position vector is the vector that expresses the position of a point from where? From the origin. Okay, from the origin. Now let's see that how to find the vector equation of a line. Okay, and what was the definition of vector equation of a line? Vector equation of a line. Vector equation of a line is a type of equation that includes vector. Okay, that includes vectors. That means the number of steps to be taken in going from one point to another point. That includes vectors. Okay, and it helps us, or it allows us to find the position vector of a point. So the vector equation of a line allows us to find the position vector of a point. Okay, and therefore the coordinate of a point. Okay, now let's start along two-dimensional considerations. Okay, let's see. This is a line, this is a line, all right. This is the coordinate axis. Okay, so here we have, this is 1, this is 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. Okay, all right. Now, for example, you are given a line like, for example, your line is like this. Okay, it doesn't look like a line. Okay, this one. So your line looks like this. Okay, so so usually the vector equation of a line has a format of this, that r, let me write at the top, right, that r, sorry, r is equal to a, sorry, not here, okay, it's disturbing a lot. So this is the line, okay, and the equation is, for example, that r is equal to a plus t into d. Okay, so this is the format of the vector equation of a line. Okay, now let me tell you what does each quantity express. Okay, so r, this r refers to the coordinate point that you are looking for, or you are trying to find out. Okay, so this r refers to the coordinate point, or the position vector that you are looking for. All right. Okay, now this a is the position vector of any known point on the line. So this is, so r is the position vector of the point, that you are looking for or searching for. Okay, and this is the position vector of the point that you already, position vector of the point on the line that you already know about. Okay, okay, so and now this d is the value of your one step, or the vector numbers of your one step. Okay, and this d is the vector number or the vector of your one step. Okay, not one unit, I am talking about one step. You know that the value of steps can vary, like you can have shorter steps or you can have longer steps. So this d is the value of one step. Okay, the vector values of one step. Okay, and this t is the number of steps that you have to take. Okay, so again, what is r? R is the position vector of the point that you are looking for. A is the position vector of the point on the line that you already know about. T is the number of steps that you have to walk from where? From your known coordinate point. Okay, so this is important. So t is the number of steps that you have to walk to find your coordinate point, and from where you will walk? You will walk from A. Okay, and d is the value of your one step. Okay, now let's look for further the meaning of d. Okay, let me wrap all of this. Now, for example, okay, excuse me. Well, I'm excused. Okay, this is the line. Okay, now, for example, when you are taking one step, then you are going from here here to here. Okay, so what is the coordinate point over here? So from here to here you are taking, so this is your one step, which we are calling it as the d. So let's see. Okay, so here you have moved from sorry. So here you have moved from 2 to 4. That means along x direction you have moved 2 units. Okay, in one step. And in y direction, let's see. So this is 2.5 and this is 3.5. Okay, so from 2.5 to 3.5, it is 1. So in your one step you have moved 1 unit along the y axis. Okay, so the vector of your one step is d equals to 2, 1. Okay. Okay, and this d is the vector for one step, and this d is, in mathematics, it is also called the direction vector. Okay, now, so our d in this case, so our d in this case is 2, 1. Okay, now we are looking for A. Any coordinate point on the line which you know can be referred as A. Okay, so this point has got a coordinate of 1, x axis, sorry, you have to, A is the position vector of the known coordinate point. That means you have to take it from, the origin. Okay, so 1 unit from O in the x direction and 2 units from O in the y direction. So A would be equal to 1, 2. That means the coordinate point you know is 1, 2. Okay. Now, what do you know? R equals to A plus TD where r is the coordinate point that we are looking for, the position vector of the coordinate point that we are looking for. A is the position vector of any given point on the line, and then d is the vector of one step that we are taking or we are walking, or is also known as a direction vector, and t is the number of steps that we have to take. Okay. Now, I am asking you to find the coordinate of a point which is situated 5 steps away from A. Okay, 5 steps away from A. Now, how would you find out the coordinate of the point? Okay, so the coordinate of the point R will be equal to the A, that means 1, 2, and how many steps we are talking about? 5 steps. And what is the vector of one step? It is 2, 1. Okay, so let's put 2, 1 over here. So it would be 1, 2 plus 5 2s are 10 and 5 1s are 5. Now let's add them together. So we will get 10 plus 1 equals to 11, and 5 plus 2 equals to 7. Okay, so the coordinate point we are looking for is situated 11 units from O, 11 units from O in the x axis and 7 units from O in the y axis. That means the coordinate point is 11, 7. Okay. So, this what refers to the vector equation of a line. Now, the same logic in the same way also applies for the vectors in 3 dimensions. All right. Okay. Exactly, everything is the same. Each and everything is the same. Okay. Okay. So, now from 2 dimensions, since all the vectors in 2 and 3 dimensions have got same type of considerations. So, let us move on directly to the vectors in 3 dimensions. All right. Okay. So, now let us learn some basics of of the vector considerations between 2 lines. Okay. For example, one line has an equation that R1 equals to A1 plus T into D1. Okay. And a second vector has an equation of R2 is equal to A2 plus S into D2. Okay. So, now the first thing that we have to consider is that are these 2 vector lines parallel? Okay, whether the 2 vector lines are parallel is that you have to consider the if the 2 vectors has to be parallel, first of all, parallel, then what you have to find out is the ratio of x values, y values and z values. Okay. If the ratios of x values, ratios of y values and ratios of z values, they are equal for both direction vectors, then the vectors, they must be parallel. Okay. For example, one of the direction vector is 1, 2, 3. Okay. And another direction vector is 3, 6, 9. Okay, so 3, 6, 9. Now are these two lines to which these direction vectors belong are parallel? Okay, let's see. So the ratio of x is 3/1, or it is 3, or you can take 1/3. Okay, the format has to remain the same. If you take d1/d2, then in all cases you have to take d1/d2. If you take d2/d1 in one case, then you have to take d2/d1 in all other cases. Like here I have taken d2 divided by d1. Okay, so these are for the x values. Now let's look for the y values. It is 6/2, 6/2, which is still 3. That means here the ratio of y values are also 3. All right. Now let's look at the ratio of z. It is 9/3, which is also equal to 3. So here the ratio of x values, the ratio of y values, and the ratio of z values are all equal. That means these two lines to which the direction vector belongs, they must be parallel. Okay. Now there is one more issue, that whether the lines the lines are parallel, but they may also be the same lines. Okay. So parallel means they are in the same direction, isn't it, which may be like this, or which may be like this, isn't it? Now this is the case that we are calling that they are parallel, but in this case we are calling that they are parallel and collinear. Now collinear actually means that they are the same straight line, because if you join their ends, okay, they would become as if they are the same straight lines. Now okay, so we have measured that the two vectors are parallel, but we didn't yet determine, okay, they are parallel, but are they collinear or are they the same straight line? To look for this information, you have to look at the values of the given coordinate points, or the position vectors of the known coordinate points on the line. Okay? If their difference is also equal, first find their difference. Okay, first find their difference. For example, take a vector which is capital D. It may be equal to A2 minus A1. Okay, or you can take A1 minus A2. It's your wish. Now compare this D with either D1 or this D with D2. Okay, any of these vectors. Now then try to calculate the ratios. Now if the difference of the given vectors and the difference of the given vectors and any one of the direction vectors, their ratios appear to be the same, either in this case or in this case, the ratios they appear to be the same, then the vectors are parallel and also the vectors are the same straight lines. Okay, like let me show you as an example, or let me tell you the logic behind it. Okay, let me draw two lines which are same straight lines. All right. For example, this is one line, this is another line. Now you can see that they are in the same direction, they are parallel, and if you join them, okay, if you join them, they will appear to be the same straight lines. Okay. Now, what is the logic of what I have said just now? Okay, so this line has direction vector d1 and this line has direction vector d2. Now, you can see here that d1 and d2 are in the same direction. So, we would say d1 is parallel to d2, or the first line is parallel to the second line. Okay. Now, for example, this is a known coordinate point on the first line and this is a known coordinate point on the second line. Now, imagine that you are joining these known coordinate points by a straight line. Okay. Now, what you see? The vector that joins the known coordinate points, does it appear to be in the same direction as d1 and d2? Exactly. That is why we say that if two lines are collinear, then their direction vectors must be parallel following the x-y-z ratio rules, and along with them the vector which is the difference between the given or known coordinate points on the line, that vector must also be parallel to the given vectors. Okay? And if now any of the vectors d1 and d2, if the ratios like the x ratios and the y ratios and the z ratios doesn't match, or if such that two ratios matched but one ratio didn't match, or one ratio matched but rest of the two ratios didn't match, then the vectors are no way they are parallel. To call two vectors parallel, all the ratios, the x, the y and the z, they must match. Okay. So, this is the theory. Okay. But remember that what I am saying is that between two vectors the x, y, z ratios must be same. This is what I am saying, that for example, the vector d, the vector small d1 and the vector small d2, they are all parallel, which means that whenever you are trying to find the ratio of x, y, z between capital D and small d1, the ratios of x, y, z must be equal. Okay. Whenever you are trying to find the ratio of x, y, z between small capital D and small d2, the ratios must be equal, but they may not be equal with this case. Okay. I mean, the values of the ratio of x here might not match with ratio of x here. Okay. But within two specific within a specific set, the x, y, z must match. That means within small d and capital D2, the x, y, z ratios must be equal. Okay. Within a specific set of vectors, the x, y, z ratio must match to call themselves as parallel. Okay. Now, our second case is that finding the angle between the two vectors. Okay. For example, one vector is in this direction and one vector is in that direction. So, you have to find the angle between the two vectors. Okay. Now, first before going into this thing, we need to know about the dot product of two vectors. Okay. For example, vector x is x1, x2, x3 and vector y is y1, y2, y3. All right. Okay. So, if I say try to find out x dot y, this actually refers to So x dot y is x1. Okay, so it will be the product of x values, the product of y values, and the product of z values. Okay, so let's write it down first. x1, x2, x3 dot y1, y2, y3. Okay, and these will be equal to x1 straight multiply I'm sorry, it was a phone call from one of my student. So we were talking about dot product. So x1, x2, x3 dot y1, y2, y3. Now if we multiply them, straight multiply, then add, straight multiply, then add, straight multiply. So it would be x1, y1 plus x2, y2 plus x3, y3. Okay? So this is what we mean by the dot product of vectors. Okay? Now we will be using this dot product of vectors to find the angle between the two lines, two vector lines. Okay. But before applying the formula for angle between the two lines, you must make sure that two lines are such that they seem to act away from a point. Okay, either both vectors away from a point or both vectors towards the point. Okay, the angle that you will find out will only be in that case. Okay, either this case or this case. Okay, and if you are applying the formula for finding angle between the vectors, then you are finding this angle. Okay, so you are finding this angle, which is the angle between the two vectors, but you have also this angle, which is also the angle between the two vectors. But the formula will tell you the angle which is such that the two vectors are both acting away from a point or acting towards a point. All right. Okay. Now what is the formula? For example, so the formula for the dot for finding the angle between the two vectors is so this is one vector, this is another vector, the angle between them is theta, and this is vector A, this is vector B. So the angle between them is cos theta, which will be equal to the dot product of the vectors divided by the modulus product, or the product of modulus, or the length of the vectors. Okay. From here you can easily find the value of theta. Okay. Now we will talk about two lines which may meet or which may be parallel or which may not be parallel but and also does not meet in a space of 2 dimensions. Okay. If two lines are parallel, then they never meet, but if two lines are not parallel, then somewhere or somehow they would meet. Okay. But this is not always the case in 3 dimensions. Okay. Now let me show you some examples. Let me turn on the camera. Okay. Okay. Now look at here. Look at over here. Okay. So this is one line. Okay. And this one is another line. This leafy thing is another line. Okay. So what do you think? This line and this line, are they parallel? No, they are not parallel. But do you think that they will ever meet? Okay, no, they will even never meet. Okay, look at here. Let's show the top view. Okay, look at here. So this line and this line, they are not parallel, right? But they will also never meet. Okay. So these lines that which are not parallel but still they will never meet is what we call the skew lines. Okay. They are not parallel and they will never meet is what we call the skew lines. Now we already have seen that how to determine that whether the two lines are parallel or not. Now what to do if now it seems that the lines they will meet because they are not parallel, or they will not meet because they are the skew lines. Okay. Okay. Now if two lines does not meet, then what happens is that just first learn something, that maybe all their coordinates are different, or two are different. I'm talking about 3 dimensions. Either all their coordinates are different or two coordinates are different. Okay. Or even one coordinate is different and the rest of the two coordinates are the same. Okay. Either all coordinates are different, or it may be that two coordinates are different but one coordinate is same. I'm talking about, for example, maybe the x and y values are the same, the x and y values are different but the z coordinates or the z values are the same. Or here in this case, for example, maybe the x values in both coordinates or in both case of both lines are the same. The y values in case of both lines are the same, but the z values are different. Or it may be anything like x values of two lines are the same, the z values of two lines are the same, but y values are not the same. Okay. It may be any one of the case, but at least one coordinate has to be different. Okay. Even if two coordinates are the same, it does not mean the line will meet. The line will only meet if all coordinates are the same. Okay. Please note it down, that the lines will only meet if all coordinates are the same. Okay. Now let us have a look at an example, an analytical example. Please forgive me for this bad illustration, like I am doing a homemade illustration and I am also wearing a typical Bengali dress, so please don't mind. Okay. So look, for example, I am focusing on this line and this line. Okay. No, sorry, this line, no, this line and this line. Okay. These two lines I am focusing on. Look, there doesn't seem to be like they are parallel. okay, because one goes in this direction and one goes in that direction. So they are not parallel, but they will also never meet. Okay. Okay, let me start over again from here. So along this rope, the direction is the y-axis, for example, okay, and along this stick over here, the direction is the x-axis, okay, and vertically from the top of this pipe, let this from here vertically down, let this is the z-axis, okay. Now look, this line and this line, they are not parallel, okay, they are not parallel, as you can see it from here. They are not parallel, but also they are not meeting, isn't it? Look at this line and look at this pipe, they will never meet, okay. So now let's move along the y-axis. So let's see that whether they are the same distance from the y-axis or not. Okay, so let me start from here. I'm starting, okay. So I'm taking step 1, 2, 3, 4, 5, 5 and 5.5. Okay, so both these lines are 5.5 y distance from the start of the y-axis. So okay, so I'm writing, for example, this pipe is the line, first line, and this rod is the second line. Okay, all right. So the pipe and the red colored rod, okay, the coordinate points. So both have the 5.5 distance from the start of the y-axis. Okay, now let's move along the z-axis. Can you okay, so I am focusing, for example, z-axis. Okay, here we go. So I am focusing, for example, this point. Okay, this point, it seems like they're meeting. Okay, so let's start. Let me count. So 1, 2, 3, 4, 5, 6, 7. Okay, so 7. So the for the pipe we have to move 7 units along the z-axis, and for the rod, let's get start from the level of the pipe again, because this is our start of the z-axis. So 1, 2, 3, 4, 5, 6, 7. Okay, so here we have again 7. So look, along both the y-axis and the z-axis we have moved the same distance. Now let's consider on the x-axis. So here is our x-axis. Okay, so this is my leg. So 1, okay, 2, 3, 4. So after 4 steps, I have reached the coordinate point of the rod. All right. So on the rod, I'm writing here 4.0. Okay. But look, I haven't yet reached the pipe. To reach the pipe, I have to go some more. That means more 0.5 steps. That means to reach the coordinate point of the pipe, I have to go 4.5 steps. Okay. So what you can see from here, that y and z coordinates, they are the same, but x coordinates, they are the different. So that's why the lines are the skew lines. Okay, we call them the skew lines because they are not parallel and they will also not meet. Now if these 2 points do meet, okay, if these 2 points meet, then they would be the same distance from the x-axis, from the y-axis, from the z-axis. All the distance would be the same because they met at the same point. All right. Okay. So if you want to prove that whether two lines are parallel, whether two lines are skew or they will meet, is that you have to solve the equation of the two lines simultaneously. Okay, and how? Let's see. For example, the equation for one of the line is r1. Okay, so r1 is the unknown coordinate points or coordinate point that we are trying to find out. Let's consider it as x, y, z, the unknown coordinate point that we are trying to find out or we are focusing. The given point is, example, consider a1, b1 and c1. Okay, and this is the number of steps, the t. No, let me put it k. Okay, and the direction vector is d1, d2 and d3. Okay, I cannot put the last bracket over here. I am trying, but I can't. Okay, so this is for the first line. Okay, and for the second line, let me write it. Let x, y and z, this has to be equal to a2, b2 and c2 plus L, which is the number of steps for the second line. It's like d1, d2, d3 I've written. So let's write here capital D. No, capital D means a different thing. So let's write here P1, P2, P3. That means this is the coordinate point for each steps. That means it's the direction vector. Now please write down these two equations because I need space to write something more, so I will be rubbing them. Okay, so I guess you have written both the equations. Okay, so for the first equation, what we have, x equals to okay, I forgot the equation myself. Okay, so let me write over again. I'm so sorry that I'm taking your time. X, y, z is equal to a1, a2, a3, or sorry, a1, b1, c1 plus k into p1, q1, r1. Okay, that's much better. Okay, this is the first equation of the first line. I mean the equation of the first line, and the second line is a2, b2, c2 plus L into P2, Q2, R2. Okay. Now I think I will remember these equations. Okay. Now I am rubbing them. So for the first equation, what can we write? What can we write? We can write x is equal to a1 plus k into p1, isn't it? a1 plus k into p1. We can write y equals to b1 plus k into q1, and we can write z, sorry, we can write z is equal to c1 plus k into r1. So, these are the equations that we are getting from the first line. Okay. Now, let us find some equations from the second line. So, x would be equal to a2 plus k plus l into p2, then y is equal to b2 plus l into q2, and z is equal to c2 plus l into r2. Okay. So, these are the two sets of equations that we have got. Okay. Now, what to do? So, this is the equation of x. Now, this is also an equation of x, isn't it? So, can we write a plus k p1 a1 plus k p1 must be equal to a2 plus l p2? Indeed, we can, because if we guess that these lines would meet, so the x coordinates must be equal, or the y or the z, whatever it is. The actual rule is you take two sets of equations. Like I always prefer taking x and y and solving them simultaneously to obtain the values of k and l. Okay. So, which equations we have taken? We have taken x, okay, and we have taken y together and solved them simultaneously to find the values of k and l. Okay. Now, we are left with the equations of z. So, now what to do? We will put the value of k over here in the equation of z and the value of l over here in the equation of z. Now, if the z values in this case they appear to be equal, like the z value here and the z value here, they appear to be equal for sure. So, we have solved x and y simultaneously. So, x and y values must match, and again, if the z values match also, then all x, y and z values for both the equations are matching. So, that is why all the coordinate points of the both lines are the same at the meeting point. So, the lines do meet. Okay. But if the x, since you have taken x and y to find the x and y together simultaneously to find the value of k and l, so x and y will be equal. Okay. But if the z values, after putting the values of k and l that you find out, if the z values doesn't match, then the lines are not the x and y are the same, but z is not matching. That means the lines would not meet. Instead, the lines would be skew lines. Okay. You might also take like that. You might prefer to take that. Okay, I will take the equations for x and z and solve it simultaneously to find the value of k and l, and then put the value of k and l in the equations of y to check. Yes, you can do it, no problem. Please don't bother about the values of k and l or the number of steps that you are taking. Please don't bother about them, because for different sets of equations the values would be different. So, that is not a problem. Okay. Okay. Now, we have to find for example, this is a line, and this is an external point. Now, you have to find the perpendicular distance from the external point to the line. Okay. And sometimes you also have to find the coordinate point, that the coordinate point at the meeting position of a line from an external point. Meeting position of a line from an external point. Okay. And it has to be a perpendicular line. Okay. So, okay. So if you have to find the distance, then you can do it in one using one single formula, which I will show you later that how to derive it. The formula is, okay, if the distance or the length of the line is capital L, no, with this color, okay, so it's capital L, so we would say that capital L would be, just remember it carefully, that vector from the external point to the given point on the line, okay, which is that we are calling it as, look, remember that r equals to a plus tb, isn't it? Here a is the given point, and here we are calling it as, okay, let me write here, calling it as g, okay. So vector from the external point to the given point is a modulus of the vector from the external point to the given point, okay, into sine okay, cos inverse. I think I won't have enough space. Wait. So I would say that L will be equal to, okay, so vector on the modulus of vector from the external point to the given point into sine, the whole thing goes into sine with cos inverse the vector from the external point. Still I won't have enough space. Okay, so L would be equal to, okay, I will just write V, okay, and it should be V from external point to the given point, okay. So modulus of V multiplied by sine of what? Sine of cos inverse vector from the external point to given point dot the direction vector of the line, okay, the direction vector of the line divided by magnitude of vector from external point to given point multiplied by magnitude of d, okay. Okay, so this is the formula to find the length of the vector, length of the line from an external point, length, I mean the perpendicular distance from an external point to the line. Okay, now what do you mean by the V here? Okay, suppose this is the line, all right. Now any point on the line is a given point, okay, any point on the line is a given point. It is G, or you can call it as A. Now this is an external point, we are calling it as E, and this is the perpendicular distance that we are looking for. And here the vector from G to E is the V, okay. So V would be equal to the external point vector, position vector, minus the given point position vector, okay. All right, now the thing is, so using this formula we can directly find the distance, but sometimes what the question wants from us is to find the meeting point on the line. If we draw a perpendicular line from an external point on another line, then they tell us to find the coordinate of the point at which the line meets, okay, the perpendicular line meets. Now this is not also that much challenging. Let's use a logic over here. Look, this line and this line, they are perpendicular to each other, isn't it? That means here the angle is 90. So now tell me the value of cos 90. Cos 90 has the value of 0, okay. So we will use the fact of cos 90 to find the coordinate of this meeting point, okay. Now let's see. Okay, now to find the coordinate point of mid of a perpendicular line from an external point, we first need to know that if two coordinate points are given, then how will we find the vector equation of a line, okay. Let's look at an example, although I will make another video on the examples of the mathematical examples of the concepts that I have used here. Still, I have to show this example right now. Okay, for example, consider one point is 1, 2, 3 and another coordinate point is 2, -3, 7. Okay, now you are asked to find the vector equation of the line that joins these 2 points. Okay, now remember the format, that R is equal to A plus TD, sorry, where A is a given point or the position vector of a given point, and we have 2 of them here. We can use any one of them, and T is the number of steps which we don't know, and we also don't need to know. It will focus on the question, or we have to find out anyhow, and D is the direction vector. Okay, now if you want to go for, suppose this point is A, this point is B. Now if you want to go from A to B, then you have to do what? You have to find B minus A, okay, B minus A. Okay, all right. Now suppose this is one coordinate point, this is another coordinate point, this is A, or the position vector of A, okay, this is B, this is the position vector of B. Now if we are to find B minus A, then it should be like 2 -3 7 minus 1 2 3, and this has to be equal to, so 2 minus 1 would give us 1, minus 3 minus 2 would give us minus 5, 7 minus 3 would give us 4. So 1 minus 5, 4, which we can use it as a direction vector, okay. So one thing is that you can either use 1 minus 5, 4, or you can use any multiple. I repeat, any multiple of 1 minus 5, 4 as the direction vector in the required line, okay. So okay, where were we? Okay, so we were finding the position vectors. So one of our vectors that we have got is 1 minus 5, 4, and we had, so this is our direction vector, and we are talking, we were telling that either 1 minus 5, 4 or any multiple of 1 minus 5, 4 can be used as the direction vector. Like you can use 0.5 minus 2.5 and 2 as the direction vector, okay. You might use 2 minus 10, 8 as the direction vector, because all of these are the multiples of this vector, okay. So the vector that you are finding directly or their multiples can be used as a direction vector, okay. Now, so we had a given point of 1, 2, 3, and we have found 1, minus 5, 4 as the direction vector. So we would say, so we would say that r is equal to 1, 2, 3 multiplied by t. You can put any random letter over here or symbol over here, no problem. T into 1 minus 5, 4. Okay, so this is the vector equation of the line that joins the two given coordinate points. Okay, the similar logic we would be using here to find the coordinate of the point where the line from an where a perpendicular line from an external point meets another line. Okay, so let's see. This is a line. Okay, so this is an external point and this is the perpendicular line. Okay, and this is the meeting point where the lines meet. Okay, okay, so for example, this line has the name L1. The color looks blurry. I think I should use okay, so this line has an equation L1. All right, and okay, now consider that L1 has an equation of R is equal to A B C plus T into P Q R. Okay, R is equals to A B C, sorry, so P Q, no, it's all right, A B C plus T into P Q R. So this R is the coordinate point to be found, so we can call it X Y Z. A B C is the coordinate point, the position vector of a given coordinate point on the line, and this P Q R is the direction vector or the coordinate of each step on the line. Okay, so we can say that X, Y, Z, which is equal to R, can be equal to A plus TP, B plus TQ, C plus TR. All right. Okay, so X is equals to A plus TP, Y is equals to B plus TQ, and Z equals to C plus TR. All right. Okay. Now, so this is the coordinate point. So I think if this coordinate point is X, Y, Z, then we can say that this coordinate point is this coordinate point has got the X value as A plus TP, Y value as B plus TQ, and Z value as C plus TR. Okay. Okay. Now I'm taking a screenshot of this. Okay. Now, so what do we plan? So this is a line and this is another line from an external point. Okay, and this is the meeting point. So this meeting point, just understand that this meeting point is a coordinate point on this line, isn't it? Okay, so this meeting point has got the coordinates of X, Y, Z, which was equal to actually A plus TP, B plus TQ, and C plus TR. Okay, and let this external point is let it would be E1 the coordinates of the external point is E1, E2, E3. It's so difficult to write. Okay, let me write it, try again. So it's E1, comma, E2, comma, E3. Okay, now I got it right. Okay, so this external, so this meeting point has got the coordinate x, y, and z, and the external point has got the coordinate E1, E2, and E3. Okay, now you already know that this line has got a direction vector which is d, isn't it? And which is equal to PQR. But this line doesn't have still a direction vector. Okay, now what can we do? Okay, let's find a direction vector for this line. And you know the direction vector, as we have seen a few moments ago, the direction vector would be the difference in the coordinates of the two extreme points. Okay, the two extreme points beside the lines. Okay, so let the direction vector here is d1. So can we say that since the two lines are perpendicular, so we can say that what was the formula for the dot product? Do you remember? It's cos theta will be equal to, okay, d, the dot product of the vectors divided by the product of magnitude of the vectors, d1. All right. Okay, and here since the two lines are perpendicular, so the angle between them must have to be 90 degree. Okay, so it's cos 90, and you know cos 90 is 0, so this side becomes 0, and if this becomes multiplied with this, it also becomes 0. So we obtain what? We obtain d dot d1 must be equal to 0, and this is a very important interpretation, that if two lines are perpendicular, then their dot product, the dot product of the directions has to be 0. Okay, let me take a screenshot. Okay, so we have the dot product to be 0. Now let's find out the what? Let's find out the d1 over here. Okay. Okay. Brush. Okay. So let's find the d1, and d1, the direction vector has to be equal to the difference in the extreme points. So one extreme point was the meeting point, which we are calling it as x, y, and z, and another extreme point is the external point, which we considered as E1, E2, E3. All right? Okay. So this is D1. That means we can tell it as x minus E1, y minus E2, and z minus E3. Okay, I'm taking a screenshot. Now what was x, y, and z? Do you remember? Look, x was let me change the color. X was equal to a plus tp, y was equal to b plus tq, and z was equal to c plus tr. Okay, now let's put the values of x, y, and z over here in this case, and then we would apply d dot d1 is equal to 0. Okay, so now if we put them all together, rather than making it more complicated, So what we should do is that the direction vector D, which we will call it, the direction vector D, which we were telling it as P, Q and R, isn't it? P, Q and R we were talking about. I'm not sure, forward. Let's see. Oh yes, it was P, Q and R. Okay, so P, Q and R dot A plus TP minus E1, B plus TQ minus E2, C plus TR minus E3, and this whole thing would be equal to 0, okay, where PQR are the direction vectors of the line under concern, and A, B, C are the given points on the line or the coordinate of any known point on the line. T is the number of steps that we have to walk, and again PQR are the duration vectors, and E is the external point. Okay, and again just notice that these points are simply the can be obtained from the equation of the line. Okay, now after finding the values, so what you will do that from here you will find the value of t, okay, and you will put the value of t in the equation of line, which was already given. Let me show you. You will put these values in the equation of line. Look, the given here, the value of t over here, and find the coordinates of x, y and z. Okay, here are the values of t. Okay, now this is how you can find the meeting point of the perpendicular line from an external point to another line. Okay, just like in this case. All right, and you can also find the distance from here, like let me show you, like after you find this quantity, this quantity is the D1, isn't it, that we were talking about D1. This quantity is the D1, isn't it? Okay, so this quantity was the D1. Now if you find the magnitude of D1, you will find the length of the perpendicular line, but to only find the length of the perpendicular line, it will be quite lengthy process. So when we are finding just the length of the perpendicular line, we might prefer to use that formula. We might prefer to use that formula just we have learned a few moments ago. Okay. Okay, so D1, this would be equal to A plus TP minus E1, then B plus TQ minus E2, then C plus TR minus E3. Okay, and the magnitude or the modulus of D1 would give you the coordinate point, the length of the perpendicular line. Okay, the length of this perpendicular line. Okay, and also the coordinate point. Okay guys, so that's the end of the conceptual video for the vector equation of a line. In the next video we will talk about some examples of all the concepts of the vector equation of a line. Okay, thank you, goodbye.